All right, let's talk about something huge. We're going to pull back the curtain on a technology that's, well, it's pretty much invisible, but it underpins our entire civilization. It's a machine you've probably never given a second thought to, but your life absolutely depends on it.
So let me ask you something. What powers the water in your city? Or the fuel for your car? What about the processing of the food you eat? Just think about your day for a second. All those things, the water, the fuel, the food, they have to get from point A to point B, right? They all rely on something to move them. So what is it? What's that hidden force making it all happen?
Well, the answer is a hero hiding in plain sight. It's the pump. Yep, the industrial pump. This thing is the unsung hero, the powerful workhorse that's just humming away silently behind the scenes of our modern world. So let's dive in and figure out exactly how it works and why it's so incredibly important.
First things first, you've got to reframe how you think about these things. Pumps aren't just machines, they are the literal heartbeat of industry. I mean it. They're the things moving liquids with the exact flow and pressure needed for pretty much every single manufacturing process on the entire planet.
And that heartbeat, it's way more fragile than you'd think. There's a saying in the industry, a single pump failure can stop the entire unit. Imagine a massive industrial plant. Just one pump fails, and the whole thing can come to a grinding, incredibly expensive halt. Seriously, the stakes could not be higher.
So how does our hero actually do its job? Well, like any good superhero, it has a couple of different identities. Two main ways to get the job done. We're talking two primary categories, and each one has a totally unique way of moving liquids.
Okay, so here they are. Centrifugal pumps and positive displacement pumps. Now they both move fluid, obviously, but the way they do it is fundamentally different. And because of that, they get picked for very, very different jobs. Let's start with the centrifugal pump. This is the most common one you'll find out there. Picture a spinning wheel, we call it an impeller, inside a case. As the liquid comes in, the impeller just flings it outwards at a super high speed. It's kind of like a slingshot. That speed, that kinetic energy, gets converted into pressure, pushing the liquid out. Simple, effective, and that's why it's the king of the industry.
Now, the positive displacement pump, or PD pump for short, is a whole different beast. Instead of flinging the liquid, it traps a very specific, fixed amount of it and then just forces it out the other side. Think of it like a revolving door for liquids. A certain amount goes in, gets trapped, and then gets pushed out. This method is absolutely ideal for moving thicker, gunkier stuff, like oil or syrup.
Okay, so we've got the two main types down, but what's actually inside these things? Let's pop the hood and take a look at the anatomy that makes these machines tick.
All right, here are the key players. You've got the casing, that's the body. The impeller, that's the spinning part that does all the work. The shaft connects that impeller to the motor. The bearings are crucial. They let the shaft spin smoothly. We're talking thousands of times a minute. And finally, the seals, which are there to prevent leaks. Every single one of these parts has to work in perfect harmony. If just one of them fails, the whole pump is down for the count.
Okay, so every hero has a villain, right? A kryptonite. For the pump, that villain is this nasty, destructive force that attacks from the inside. We're calling it the bubble menace.
And here's the thing. The biggest threat to a pump's life often comes from what's happening before the liquid even gets to it. The quote says it all: poor suction destroys pumps. If you don't get the conditions right on the way in, you are just asking for a disaster.
And that disaster has a name: cavitation. So what is it? It's what happens when the pressure on the suction side of the pump drops so low that the liquid literally starts to boil. And I don't mean from heat, it's boiling because of the lack of pressure. This creates these tiny vapor bubbles, which are basically microscopic grenades just waiting to go off.
So let's walk through this attack. First, the pressure drops way too low, and these little vapor bubbles form. The liquid is essentially boiling. Then, as these bubbles get swept into a high-pressure zone inside the pump, bam! They suddenly and violently collapse. This implosion releases a massive shockwave of energy that literally blasts tiny pieces of metal right off the impeller. You do that over and over, and you'll destroy the component. The sound it makes, it's like the pump is gargling gravel. It's a machine's absolute worst nightmare.
So with a villain like that, how do you protect the hero? How do you keep the pump safe? Well, that's where another hero enters the story: the human operator. These are the guardians, the people on the ground tasked with keeping that industrial heartbeat steady and strong.
You see, operators are basically trained to be detectives. They use all their senses to monitor a pump's health. That checklist you see, it's their guide. If they hear an abnormal noise, that could be cavitation or a bearing failing. If they feel too much vibration, that could be a misalignment, which can lead to catastrophic failure. A leaky seal, overheating, each symptom points to a cause. By connecting those dots, they can step in before it's too late.
Really, it all boils down to discipline. A correct startup is key to preventing damage right out of the gate. Constant monitoring during operation lets them catch problems early. And a safe, by-the-book shutdown protects not just the machine, but also everyone working around it. That's the core of an operator's job right there.
So, as we start to wrap this up, let's circle back to where we began. These machines are so much more than just pieces of equipment. They are powerful, unseen workhorses. They are a foundational pillar of our society, making everything about our modern world possible. Think about it. The water in your home, the energy powering your city, it's all moving because of these incredible machines. So the next time you're near a factory, or heck, even in the basement of a big building, just stop for a second and listen. That steady hum you might hear, that's the world's heartbeat. It's the hum of a pump. Can you hear it now?